What is up, math class? It's Mr. Ohashi here, and today we're going to continue to work with repeating decimals, but this time they're going to be a little bit harder. See, this repeating decimal here has a repeating bar above the 5, but not the 2. So the way we write this out is 0.2 and just the 5 repeats. So it'll look something like this. 0.2555555 forever. Okay? And we're going to learn how to change that into a fraction. Now, it turns out we've learned how to change a repeating decimal to a fraction when all the digits repeat. Like if the 2 and the 5 repeated, both of them, then it'd be 25/99ths. But this time, the 2 doesn't repeat, so our little pattern doesn't work. We're going to have to use some algebra to figure out what fraction this is. So I'm going to break it down for you in 5 steps. Step 1. We are going to set x, that's our variable that we're trying to figure out, and it's going to represent our fraction. We're going to set x equal to the repeating decimal, 0.25555 ... All right? Step 2. Now, we are going to count how many digits are repeating. In this case, just the 5 is repeating, so there's only one digit repeating. Whenever one digit repeats, we are going to multiply both sides of this equation we wrote by 10. Why 10? You're going to find out in a little bit. If 2 digits were repeating, we'd multiply both sides by 100. If 3 digits were repeating, we'd multiply by 1,000. Now you're probably thinking, why are we going to do that? So when I multiply both sides by 10, 10 times x gets me 10x. Drop down my equal sign. 0.2555555 repeating multiplied by 10. Anytime you multiply a decimal by 10, you just move that decimal place over one spot. So this becomes 2.5555 repeating. Okay? So that's what we have so far. We have these two equations, x equals this and 10x equals that. Step 3, we are going to subtract the two equations. What does that mean? Well, I'm going to take this equation that I have right here, the 10x equation. I'm going to take the original equation, x equals 0.2555, and notice how I lined up the decimals. And I lined them up because I'm going to subtract the two equations from one another. Okay? And when I do that, 10x's minus 1x leaves me with 9x's. The equal drops down. Now watch what happens when we subtract right here. 2 minus 0 is 2. Drop down my decimal because it's lined up. 5 minus 2 is 3. And watch this. 5 minus 5 is 0. This 5 minus 5 is 0. This 5 minus 5 is 0. All the 5s that go on forever here, there's 5s that go on forever down here too. And they'll all subtract out to 0 forever. So when you subtract those two repeating decimals, your result is a decimal that no longer repeats because they all subtracted out and there's none left. So we end up getting just 2.3. And that's the reason why we multiplied by 10, because by shifting that decimal over one place, when we subtract them, we end up with a decimal that no longer repeats. Step 4, solve this equation. Now you learned how to solve equations like this last year. It says x times 9. To undo multiplying by 9, we divide by 9. But what you do to one side, you have to do to the other. And I use the division bar when I divide. All right, multiplying and dividing by 9 undo each other, but x drops down, equals drops down, and 2.3 divided by 9 is not a whole number, so I'm going to leave my answer as a fraction. 2.3 divided by 9 is 2.3 ninths. Do you see what I did there? Dividing and fractions are the same thing. So 2.3 divided by 9 is 2.3 ninths. We're almost done. Step 5. Make sure the numerator is a whole number on your fraction and then reduce your fraction if necessary. Right now, we have a very complicated fraction. You're not allowed to have decimals in a fraction. So what would we have to multiply the top by to make this not a decimal? The most obvious way to do this is to multiply it by 10. But on fractions, you have to multiply the top and bottom by the same number. So let's do that. 2.3 times 10 is 23. 9 times 10 is 90. Can we reduce this? 23 is a prime number, so no. 23/90ths must be the fraction that's equal to that original repeating decimal. And if you're not sure, let's check it on your calculator. All right. Does 23 divided by 90 equal 0.255555555? There it is, 0.255555555. It's always good practice to kind of check your answer with a calculator because it's super quick to do that. All right, let's do a harder one. See, this example, we had one digit repeating. Let's do one where there's two digits repeating now. We'll do 0.316, where just the 1 and the 6 repeat. Okay, so this is really equal to 0.31616161616 forever and ever and ever. Okay, so let's go through the steps. Step 1, set x equal to the number. X is equal to 0.3161616 ... Okay, step 1 done. Step 2, how many digits are repeating? In this case, 2 digits are repeating. So we're going to multiply both sides of this equation by 100 this time. When there was 1 digit repeating, we multiplied by 10. 2 digits, we multiplied by 100. And when we do that, 100 times x is 100x. And 100 times this, well, whenever we multiply a decimal by 100, we move that decimal over 2 places. So this becomes 31.6161616161661. All right, step 2 complete. Now we have 2 equations here. Step 3, we're going to subtract the 2 equations. So here's one equation. I'm going to take the original equation and put it underneath it. X equals 0. And notice I'm going to line up that decimal point with the other one. 0.3161616 ... All right, and now we can subtract the 2 equations. So on the left side, 100x's minus 1x leaves you with 99x's. Drop down my equal sign. On the other side, we gotta subtract. 31 minus 0 is 31. Drop down my decimal. 6 minus 3 is 3. And look what happens after that 6 minus 3. 1 minus 1 is 0. 6 minus 6 is 0. 1 minus 1 is 0. 6 minus 6 is 0. And remember, this repeats over and over and over again, but so does the bottom one. So they will always subtract out to 0. So again, when you subtracted those 2 repeating decimals, you get an answer that's not a repeating decimal anymore. You end up with just 31.3. Now we can figure out our answer. Step 4, solve the equation. It says x times 99, so we're going to divide by 99. But what we do to one side, we have to do to the other. All right, so multiplying and dividing by 99 undo each other. X drops down, equals drops down. 31.3 divided by 99 is not a whole number. So I'm going to keep it as a fraction. 31.3 divided by 99 is 31.3 99ths. Ooh, that's kind of hard to say. All right, last step, step 5. Make sure your fraction has all whole numbers in the numerator, and then reduce if necessary. We have a decimal in our numerator, so we're going to have to multiply the top and bottom by 10. Because when we do that, multiplying the top by 10 makes 31.3 313. 99 times 10 is 990. Can this be reduced? No, it cannot. You can try, but it cannot. It's a pretty big number. So that tells me 313 990ths is equal to 0.31616161616. And again, we should check it on our calculator just to make sure. 313 divided by 990, 0.31616161616. All right? So that's what we learned in class today, and that's what you're going to be doing on today's assignment. Don't forget, if you get stuck or you need help, feel free to email me or message me and I can help you. But with that being said, good luck on the problem set, and I will see you next time.